So if they ask you about utility, then the utility is going to be quadratic below the mean, and then it's going to be linear above the again above the mean. I'm not going to speak much on this, but then if they do, you can just write it this way. So shortfall probability measures probability. I mean, like again, semi-variance measures variance below the mean, right? So since it measures the variance below the mean, you can write it like this. It's gonna be, in terms of discrete, it's gonna be the sum of your x being less than x bar, where you will have x minus x bar squared p p of x, right? So this is how you find the variance, I mean, like semi-variance. And then you can see that when you have a distribution of return that is symmetrical, such as normal or maybe uniform, semi-variance is going to be a half, because you're only looking at one part, like you're only finding, you adding this part, something like this parts over this parts over here. So your answer is going to be 1 over 6 sigma squared. So it's going to be half of your variance, right? So in semester test 2, you saw that there was a question which asked you to calculate semi-variance. I think it was 1 or 2 mark. So it is because they expected you to just write 1 over 2 variance squared. Okay, actually variance. So what is the problem with this risk measure, semi-variance? The problem is that it measures risk below the mean. What if you want to have your own benchmark? So when you want to include your benchmark, then you can go to shortfall probability, right? So shortfall probability, as the name suggests, is a probability, and it measures the probability below your own specified benchmark, right? So instead of saying the mean, you can now just say 0%, or you can say -1%. So you can try to find the answer based on the benchmark you ask. So this, in other words, is going to be is the probability, right? So it's going to be the, in terms of continuous, it's going to be the integral from -∞ to 1 of your distribution f of x d x. So this is how you will find your answer, right? So you can do the same for discrete. For discrete, you will have the sum of your x's below L, right? And then you will say the probability of x, right? So anyway, this is how you measure your probabilities. There is another thing that you also have to take into consideration. I think I should teach it now. Here is called, okay, what is the problem with this one is that it only, there's someone who want to join? Okay, welcome, Lisa. So anyway, I am going to teach you expected shortfall right now before I move to VAR. So the problem with shortfall probability is that it talks about probability. It doesn't quantify the value. So what if we want to quantify it, like saying you have 20% probability says nothing, right? So you would want to find the probability times the loss or the losses below that benchmark, right? Then this is when you move to expected shortfall, right? You will call it expected shortfall. It's gonna be the expectation. In the book, I think they wrote it like this. They say maximum of L minus X and 0, right? Or in other words, if you wanna write it in terms of continuous, you will say is the integration of from negative infinity to L 1 minus X f of X dx. For discrete, again, your X is gonna be less than L, right? L minus X, the probability of X. So this is how you find your shortfall probability, right? So I hope this makes sense. Is there any question? In expected shortfall, expected. Any question? So remember that you can raise your hand, or you can raise your hand, or you can stop me, or you can type in the comment box, in the chat box. So we are going to do a question. So someone sent me this question again. It's from the Institute and Faculties of Actuary. 9 marks. Don't be surprised by the marks. It's because they want to give you 9 marks for a question like this, actually. So they're saying that Adam, Brad, Charlie all offered the choice of investing their entire portfolio in either a risk-free asset or a risky asset. I think I should write them down. I will have Adam. I will have Brad. I will have Charlie. So they are all given the opportunity to invest in either risk-free or risky asset. I will start with risk-free because okay, nice one. There is no need for risk. So the risk-free return, the risk-free asset offer a return of 0%, right? The risky return offers 0% return, right? Whereas the return on the risky assets are uniformly distributed. So the returns on on this other one are going to be uniformly distributed between -5 and 15 and 10%, actually, and 10% and 10, right? So assume that each individual make his own investment choice in order to minimize his expected shortfall. Right? They're looking at the expected shortfall, and that they have benchmark of negative. Okay, we have benchmarks now. The benchmarks are going to be -2, 0, and 2% respectively. Who will choose which investment, and comment briefly. So how do you find the return for this one? So to find the probability for this one, is going to be what? It's going to be so the CDF is going to be this way. We can say F, capital F of risky asset. It's going to be 1 over the integral from -5 to x of 10 minus -5 dx, right? Actually, it's not dx, dt. dt is going to be equals to -5 x 1 over 15. dt. So you will have x plus 5 to 15, right? This should be your answer. I think I wrote this thing somewhere. Yes, this should be your answer, right? So you are trying to the shortfall probability, right? So here, what they say, they said the expected shortfall, right? So when you want to find the expected shortfall, I know that in essence, what they are asking is over here, expected shortfall. So you will say our benchmark is what? Our benchmark is -2 for one angle. So we are going to do the shortfall for one for 3. So how to find the expected shortfall? I think I need to move these things a little bit this side. You have your benchmark over there. So the formula for expected shortfall, L minus X, right, to L of f of X, right? So you have negative infinity, right? So this is how you are going to find your answer. Né? So for a risk-free return for Adam, he has, again, the benchmark is going to be -2. So -2 minus 0 is just going to be -2. So I think it's going to be -2 times what? Times the probability for risk rate is just going to be 1. So he's expecting to lose -2 rand for risk-free asset, like definitely, right? So this is going to be the shortfall, and then for number 2, the shortfall is going to be 0. So you will have again L. So you will have what? You will have 0 minus 0 times 1, right? So the answer is going to be 0. So this is in terms of expected shortfall, right? I am not calculating shortfall probability. I'm calculating expected shortfall, right? The other one is gonna be 2. So you have a benchmark of, so you will say 2 minus 0. Again, you are going to have 2. Do you have any question? And by the way, who sent me this question? Are you in the group? Okay, anyway, it's fine. So if you're not here, I get the question. Okay, the person is not here, so it's fine. So we are going again. So we have benchmark of now we again the benchmark is going to be 2. I am only going to do for Adam in terms of risky assets, right? So because the distribution I had already butchered this distribution, I didn't find so the thing was supposed to be L minus X of X, and f of X is going to be 1 over again 15 actually, right? So f of X is going to be 1 over 15 d I think I should say f of t instead. F of t from -5 to L, right? So if this is the case, you can see that for someone like Adam, whose benchmark is going to be 2, you will have the integral from -5 to -2, right? It's gonna be -2. And then you start to solve for this thing. And then you will have this one, f of t dt minus the expectation from -2, -5 x. It's supposed to, I can say x. Okay, I will have to put x's over here because I already am using x's. I'm sorry for that, x. So anyway, you will have x, f of x dx. So this one is going to be relatively easy. You will have -2 plus 5 over 15 minus it's going to be x squared over 15. Right? A derivative of x squared. Sorry, I am very bad in terms of integrating. It's going to be 2x, right? So you will have actually 30. You will have something over 30 over here. You will have 8, right? From -2 to -5. And then you find the answer. So this one is for Adam. This one is for Adam. So this is how you find the answer actually. So in some places, when they describe the shortfall problem, okay, in our course, you should just stick to this definition of expected shortfall. So this is the definition you should stick to when it comes to expected shortfall. Don't use any other definition. You should always try to stick to this one, which is also in the book. So there are actually other places where you can find other definition of shortfalls. But my advice is that you should always try to stick to this one. I didn't think that this thing was going to be a little bit tricky to. But anyway, we're going to move to the next question. Say that an investor is considering investing. Okay, yeah. I think this one is from 2014 exam. So anyway, an investor is considering investing in one of two assets. The distribution of the return for each is shown below, asset 1 and asset 2. So they want you to calculate the variance. Okay, now this time I'm gonna look at the variance for asset 2. I'm not gonna do for both of them. And then they want you to find semi-variance. Okay, I assume that we can all find variance, right? So I am going to look at semi-variance, or should I find variance? I am going to look at semi-variance and shortfall probability. I shouldn't find variance, right? So anyway, we can find even semi-variance. I think it's okay, fine. Semi-variance. Semi-variance is gonna be equals to first of all, we need to find the mean, right? So to find the mean return, say that you're gonna have 0 with 50% probability. Then you're gonna have 25 with 50% probability. The return for asset 2, this is for asset 2. The return for asset 2 is gonna be 12.5%. So this is the return for asset 2. I hope it makes sense. So semi-variance is gonna be the variance where the return are going to be less than 12. I'll have r minus r bar squared the probability. So this is going to be there is only one return which is going to be lower than 12,5, which is going to be 0. So you will have 0 minus 12,5 squared with 50% probability, and then you find your answer. So shortfall probability, again, I am going to look at it as a 2, not 1. So for shortfall probability, you're just going to find the probability is going to be the sum of the probabilities of x, of capital X being equal to x, where x is going to be less than 0%, right? So this one is going to be 0% actually. Shortfall probability is going to be 0% for asset 2. Any questions? This is for 2. I think I will have to find for 1 as well, so that you can understand the sum of where x is going to be less than 0% for 1, which asset has less than 1%. So asset 1 has negative 1%, right? And that 1% has maybe 8, 1 and 2, I mean like 1.5, 1/3 percentage. I hope this makes sense. I will move on now. I think these things are not that difficult. We can try to do them. There's more questions from last year's paper. Should I do last year's paper or should I move to the next section? Should I move to VAR or should I do one last question? Okay. Okay. Lisa, are you also good? I hope so. I hope you are good. So again, this one is it's last minute preparation. I am not gonna go deeper into concept, but I want to help you answer the question, right? This is the point of this session actually, is to help you answer question, is to help you understand in the very least the basic concept that we have to do. So VAR, again, so under shortfall probability, under shortfall probability, we say that shortfall probability can be described this way. Is basically the probability below a benchmark, right? So, and I say that again, in a sense, say that there was a problem with the shortfall probability. Was that it only looks at the probability, but then it does not quantify. Now, when we move to VAR, VAR actually look at the amount we are reasonably sure we will not exceed in any, we cannot exceed at a certain confidence level, right? So this is basically VAR. So again, so if this is your alpha, if this area over here is your alpha, this wall over here, which blocks it, the value that you find, it's your VAR, is the value of VAR, is what we call VAR, is the amount we are sure we cannot exceed, right? So in other words, for a continuous variable, VAR of x is going to be the number negative t, where the probability x is going to be less than t, right? So we cannot exceed that value of t. So this is normally the return, right? The rate of the return. So it's basically the return we cannot exceed at this interval. I mean, like at this, yeah. It's gonna be the rate of return. Normally, not always. Sometimes they can try to trick you, but then this is usually the rate of return. So is the returns you are reasonably sure you cannot exceed, as the formula described. So this one is for discrete, is for continuous. For discrete, you follow the same thing, but then you say that t is going to be the maximum value of x, right? Such that the probability of x less than x is going to be equals to less or equals to. I think I will just call it alpha for now because I forgot these Greek symbols. So this is how you describe your var, right? So one of the most classic question they like to ask in the exam is this one over here. Is this question over here? Show that var can be written in this form, right? I will apologize for those people whom we have done this together, but then I am going to repeat this thing again. So to show that this is the case, this is what you are going to do. You will say that we already say that var is going to be the value of negative t, where we have the probability where x is going to be less than t, right? So how do we find this? They tell you that x is the rate of return, right? Is the rate of return and is normally distributed with mu and sigma squared, right? So if this is the case, this thing will be, okay, then it is going to be much easier to standardize actually. So you will have x minus mu over sigma. It's going to be t minus mu over sigma. And therefore, this thing is going to be equals to z less than t minus mu over sigma. I guess we can all get to this point, right? So there is another important thing. It's actually by definition, right? By definition, z is going to be less than it's going to be less than this, the inverse of the standard normal function, right? And if this is the case, you can write this. You can write this thing. You'll have the inverse of the standard one. It's going to be equals to t minus 6 sigma squared. And then you just solve for t, and then you will have your t as the sigma inverse. You can have the mu this side. So this is how you find your t, right? And then when you take it back to var, you know that your var is going to be negative of mu plus sigma this. So this is the question they asked you actually. So this is how you find your answer. So you won't even take 2 minutes answering this question. You just have to practice it. Maybe if you do it once or twice, you will feel comfortable. So anyway, I'm gonna move on to the next question, right? Are we all good here? Should I repeat or should I tell you something? Is there something you want to know? So anyway, for those people whom we are repeating this session, we did continuous last time. I did not do discrete, so I am going to start with discrete, right? I am going to start with again, we're gonna look at y. We say that y has this kind of distribution, has negative 15 with 4%, 1% return with 20%, 10% return with 60% and 20% return. With 16%, 5% VAR, 5% VAR for a discrete name. My advice is that you should try to write down the CDF. Try to write down the CDF. This is my advice because it will help you visualize. If you are unable with solving for finding VAR so far, my advice is that try to find the CDF. It will help you solve these things faster. And try to put your returns in order, right? So they start from negative 1, 10, mix them up. You should try to put them in order, right? So this will do. So we have the returns, we're going to have the CDF, right? So we have negative 15, we have 1, and the other one is going to be 20. You will have 20%. And then you're going to have 0, 0, 4, 0, 1. It's going to be 0, 2, and then 0, 6, 0, 18, 1,6 actually. So the CDF when it starts going to be 0, 0,04, 0, 0,24, 0, 0,84, 1, right? Then you're going to have 1. So they want you to find a 5% VAR, right? They want you to find a 5% VAR. Remember that we know that VAR is the value of negative t, where t is going to be the maximum value of x, such that the probability, this is supposed to be the small x, such that the probability of x less than x is going to be equals to 0,05, right? Less or equals to, which return have probability of 5% or less in terms of CDF. This one does not qualify because it's not 5% or less. It does not qualify because it's not 5% or less. It does not qualify because it's not 5% or less. Only one of them has the returns which has the probability of less than 5%. So you are basically, in other words, you are trying to find the maximum value of negative 15. You only have one value. So your answer is going to be negative 15. So your VAR is going to be negative 15%, right? So actually it's going to be negative times negative 15 times negative 15. So which is going to be 15%. So because they already told you how much the value of the investment, you can multiply this thing by the value of the investment. Okay, let's call it age in this case. So you will have 15% times the million, because that's the value of the investment. 15% of a million is going to be about 150,000. So this should be in terms of discrete. Are we confident? I mean, like, are we comfortable now? Are we clear? Or should I make my own question, because I can't find a lot of question for continue, I mean, like, for discrete action. Any questions? We have a minute to conclude. Okay, I will make my own question. But then we actually have a minute, so the session is gonna cut us. So please rejoin. Do you guys want a break? Okay, no break for now. We will make a break after we're done with, or at least after we're done with risk measures. So I am going to end the session. Please rejoin.